Very good evening and welcome all of you. Very good evening, guys. How are you all? All right. Very good evening, guys. How are you, everyone? Everyone can see and hear me properly? All right, guys. चलो. So आज हमारा session number 2 है and we are going to discuss some really important questions from the previous years, which I think must be included in your practice. Please once confirm if all of you can hear me properly. So ये जो series है, in this series we are going to be having the most important 7 sessions in which we are going to be discussing all the important questions of inorganic as well as organic chemistry. ठीक है. सो सभी कोई देख सकते हैं मुझे अच्छे से? एवरीथिंग इज क्लियर, वॉइस इज क्लियर. गुड इवनिंग गाइस, गुड इवनिंग. जॉइन अप क्विकली एंड देन वी आर गोइंग टू स्टार्ट आवर प्रैक्टिस. आई होप गाइस कि आपकी प्रैक्टिस काफी अच्छी चल रही है, अच्छी चलनी भी चाहिए. लास्ट टाइम है जो बहुत इंपॉर्टेंट होता है प्रैक्टिस के लिए. ऑल राइट. वेरी गुड इवनिंग ऑल ऑफ यू. चलो, लेट्स स्टार्ट अवर डिस्कशन नाउ. एवरीवन इज हियर. पहला क्वेश्चन करते हैं आज का. सो दिस क्वेश्चन इज फ्रॉम द गेट एग्जामिनेशन. ठीक है, ऐसा कहीं नहीं लिखा है कि आप CSIR नेट का एग्जाम दे रहे हो तो गेट के क्वेश्चन प्रैक्टिस नहीं कर सकते. यू हैव टू प्रैक्टिस क्वेश्चंस फ्रॉम बोथ CSIR नेट एंड गेट एग्जामिनेशंस. ऑल राइट. सो या, फर्स्ट क्वेश्चन फॉर टुडे. Let's see what do you answer. With respect to the reactions shown below, the correct statement about their stereochemical nature is. All right. First question. Again, dynamic stereochemistry. या फिर stereochemistry in reactions. Stereo selective reaction. Yeah, what is the correct answer? Yes, practice has already started. This is our first question. Question number 1. All right, Asif, you are saying it is A. What about the others? इस टाइप के जो क्वेश्चंस होते हैं ऐसे गेट को बहुत पसंद आते हैं. गेट एग्जामिनर ऑलवेज लुक्स फॉर सम काइंड ऑफ सिलेक्टिविटी, वेदर इट इज स्टीरियो सिलेक्टिविटी, केमो सिलेक्टिविटी या रीजियो सिलेक्टिविटी. हमेशा सिलेक्टिविटी वाले क्वेश्चन ही उठाते हैं. या, इट्स अ प्रीटी सिंपल क्वेश्चन. So the question is asking you that here I have given you two compounds. What is the relationship between 1 and 2? पहले तो ये देखो that they are looking very similar but they are not exactly the same. Yes, what is the relationship between them? और ये जो reaction करने वाले हैं, what is going to be the product P and Q? It's a very simple question. Right, चलो देखते हैं. So 1 and 2 are basically enantiomers to each other. कैसे? ये देखो. Sorry, these are diastereomers to each other. ठीक है, क्योंकि ये जो कार्बन है, this chiral carbon, this is the same. All right, it is having the same configuration. However, the other chiral carbon that has swapped its groups. तो ऐसे जो दो मॉलिक्यूल होते हैं इनको हम डायस्टीरियोमर बोलते हैं. 1 and 2 are diastereomer to each other. May that be. अब LD का क्या काम है? What is the LDA doing over here? LDA is here to remove this proton and make the enolate like this, isn't it? LDA तो enolate बनाएगा ना ester से. All right, so let's say the LDA makes an enolate. But the thing is कि when the LDA has removed this proton and made the enolate, enolate के बाद में जो ये group है alkyl bromide, let's say I'm writing alkyl bromide, where is it going to be put? It is going to be attacked like this, and definitely without any doubt it is going to be put above the plane on this carbon, क्योंकि जो भी incoming group होता है उसको least hindered side से ही attach होना होता है. So the least hindered side is the above side since the isopropyl group is present below, isn't it? तो दोनों में same होगा ना. In 1 and 2 the process is same because once you are removing this proton above है या below है, it doesn't matter. Proton removed, it gives you a planar enolate. It gives you a planar enolate. Once the enolate is planar, उसके बाद में the incoming group for both the molecules is going to attach on the same side. So what is the relationship between P and Q? P and Q are the same compound. तो इसका मतलब ये हुआ कि reaction stereo selective नहीं है. It is stereo selective. The reactions are stereo selective, but P and Q are the same. तो because की जगह यहाँ but होना चाहिए, but the question language is like this. Because का कोई रोल नहीं है यहाँ पे question में. P and Q are same, लेकिन जो reaction है वो stereo selective ही है. It is not non-stereo selective. All right, so A is correct. Now moving onwards with our second question of the day. This is from coordination chemistry. You have to find out the CFSE value. The option showing the correct match of metal complexes in column 1 and the corresponding Delo value in centimeter inverse value in column 2 is second question of the day. Yes, everyone has to answer, guys. Yes, everyone has to answer. It's pretty easy. So the questioner is asking you CFSE value, del O value, based on what? किसके basis पे पूछ रहे हैं? कुछ तो common होगा. Yes, yes. All right. So the CFSE value, उसके बहुत सारे factors होते हैं on which it is going to be dependent on. First of all, yes, Rugesh, Asif, it's correct. It's option number A only. So what are the factors? There are plenty of factors. For example, the type of ligand, whether it is a strong field or a weak field ligand. For example, the size or the nuclear charge on the metal, whether it is 3 plus, 4 plus, 2 plus, कैसा charge है metal पे, size of the metal, all those things. All right. तो यहाँ पे अगर हम देखें, so this titanium TiF63 minus, here the ligand is a weak field ligand. And for manganese also the ligand is a weak field ligand. लेकिन फिर भी टाइटेनियम का जो ऑक्सीडेशन स्टेट है that is +3. For manganese also it is +4. So that means even though the ligand are weak field, the CFSE is going to be good enough. What about the cobalt complex? ये देखो इसका चार्ज है 3 plus and it is having a very strong field ligand. Actually this is the strongest of all the other ligands. So charge is also high as well as the ligand is also strong. So this is going to have the maximum value. isn't it? So the value 24,000 that is going to be matched with cobalt complex. ठीक है, अब आगे चलते हैं guys. इसके बाद कौन होना चाहिए? Strong manganese होना चाहिए because the charge is very high on manganese. So we can say that manganese could have 21800 centimeter inverse. अब अब आता है titanium 3 plus and iron 2 plus. So titanium 3 plus, the size is small as well as you are having only D1 electron, as well as you know there's +3 charge. तो इसका जो value रहेगा that is going to be higher than iron. iron के लिए हम match करेंगे 9400, लेकिन इसके लिए हम match करेंगे 17,000. And if you have gone through the books, you will kind of remember कि titanium के जो complexes होते हैं, the value starts from like 17,000 and so onwards. इससे ज़्यादा ही होता है, इससे कम नहीं होता. All right, so this is going to be 9400. If you study the D1 octahedral complex, Orgel diagram and so many things, you will see कि यहाँ से start होती है titanium की value. So A is the correct answer. All right, चलो let's move onwards. The correct statement regarding the following physical property is, so out of these properties, which is the correct statement? Yes, everyone has to answer, okay? All right. So which of the following is the correct physical property? Yeah, it's not that difficult. कल ही हमने एक ऐसा क्वेश्चन फॉलो किया था. That bond order, we have seen the bond order for nitrogen is the maximum, but bond order for carbon is 2 and for boron is 1. तो ये तो वैसे ही wrong हो गया. Melting point is going to be the highest for ammonia because of hydrogen bonding. So this is wrong again. Pauling electronegativity and first ionization energy. पहले इसको देखते हैं, first ionization energy को. So what is the electronic configuration? This is 2s2 2p2. Beryllium is going to be 2s2. Boron is 2s2 2p1. Then comes 1s2, isn't it? So guys, how is this order going to be correct? Because definitely beryllium is going to have the minimum first ionization energy. All right, because the electron is present in the 2p1 and lithium is going to have higher than beryllium, isn't it? And guys, beryllium as well as boron की सबसे ज़्यादा कम होनी चाहिए और beryllium की सबसे ज़्यादा होनी चाहिए यहाँ पे. So D is also not correct. No, it's going to be option number C. Pauling electronegativity, you see phosphorus, sulfur, acha, sorry. Let me just write it like this. Yeah, in the third period, it is going to be like this. All right, sulfur has a greater electronegativity than phosphorus. Then comes silicon, then comes aluminium. तो ये sulfur पहले आएगा rather than phosphorus. Right. So C is wrong. We have to check for the other option only. Let's check once again. All right. So first ionization energy, the electron to be removed, is there in the 2p2 orbital? Then maybe because this decrease in size is doing so. No, this is wrong. This is wrong. Melting point order is also wrong. पॉलिंग इलेक्ट्रोनेगेटिविटी, सल्फर पहले आएगा फॉस्फोरस के, इसकी सल्फर की ज्यादा होगी इलेक्ट्रोनेगेटिविटी एज कंपेयर टू फॉस्फोरस, सो दिस ऑर्डर इज आल्सो रॉन्ग, सो डी इज द ओनली ऑर्डर विच इज लेफ्ट. ऑल राइट, चलो डी मार्क करते हैं क्योंकि बाकी सारे रॉन्ग हैं. So the only possible answer is D because all the others are wrong over here. Chalo, let's move onwards to another important question from coordination. Electronic spectrum of an aqueous solution of nickel 2 plus hexa aqua complex shows three distinct bands. So one band is at 400 nanometer, B is at 690 nanometer and C is at 1070 nanometer. Transition assigned to A, B and C respectively are. Yes, sorry Rugesh, sorry I just made this a mistake. So yes, there is going to be S1. All right, it's there in the alkali metals, so it is going to be 1s to 2s1. So the removal of this one electron is easier, I guess, as compared to the amphoteric B boron. All right, so as we move from left to right, the electronegativity increases, right? That's why boron being more electronegative than lithium. Right. Chalo. Now we move onwards to this. So Orgel diagram में अगर आपको याद हो, what have I told you, to try and remember the combined form of Orgel diagram for all the electronic configurations. ठीक है, so when we are talking about nickel 2 plus D8 system, how is it going to split? Is it going to have the D term or the F term? आपको देखते ही याद आ जाना चाहिए, इतना सोचने का टाइम नहीं लगता है गाइस. Two unpaired electrons, so it is going to be 3F. All right, so in the examination all you have to do is D1. Yes, in the examination you have to do D1 and D6, D4 and D9. They are going to have same spectra. And for the D2 and D3 system, देखो जहाँ पे F term आ जाता है ना, F term and the P term. So for the D2 and D7 octahedral and the D3 and D8 tetrahedral, we are going to have the same spectra. For the D2 and D7 tetrahedral and D3 and D8 octahedral, you are going to have the same spectra. तो जो common diagram होता है, that is going to be it's going to be good if you remember that. Okay. Alright, so this is how the spectra is going to be for the D8 system. ये रहा D8 octahedral system. तो यहाँ से हम देखेंगे first transition, the lowest energy transition which is given to be 400 nanometer corresponds to A2G to T2G. कितना 3F term है तो 3A2G से 3T2G, ये होगा first वाला. So respectively पूछा है, so we are going to write A is going to be A2G to T2G. This one A2G to T2G. All right, the second one is going to be from A to G to 3T1G. All right, this is correct too. 690, and the highest energy transition is going to be from 3A to G say 3T1G. So 3A to G say 3T1G of the P. So C is the correct answer. All right. Please understand this, that if you remember the Orgel diagram of the D and the F in a combined format, it is going to be easier for you to answer for all of these electronic configuration. So this is the correct answer, option number C. आगे चलते हैं to our next question. ये देखो, The correct match for the molecule given in column P with the spectral data given in the column Q is. Yes, आसिफ, ये देखो सबसे बड़ा transition. Okay, sorry. It is actually given in the wavelength. Wavelength format it is given. Wavelength is inversely proportional to energy, isn't it? Yes, it's given in the wavelength format. So when we are talking about this A 400 nanometer shortest wavelength मतलब highest energy. Energy wise it is going to be A less than B less than C. C की energy सबसे ज़्यादा है तो हम यहाँ पे इसको C लिख देते हैं. Sorry, सबसे कम है C की energy. Yes. All right. So C and then B and then A. Let's label it like this. Chalo. So C is going to be the shortest one. That is the A to G to T to G. A to G to T to G looks like this. Then comes B, which is A to G to T1G. And then comes C, which is the highest energy one. A, that is A to G to 3T1G coming from the P. So is B the correct answer, all of you? Yes. अगर हम लैम्डा से देखना चाहें तो energetically A is going to be the highest energy transition over here. So this becomes A, this one. चलो आगे चलते हैं. Next question 40. Now see, this is a spectroscopy question. So how are they going to absorb? This is our ethyl acetate, 2-chloropentane, and this is 1,2-dibromo, 2-methylpropane. बहुत easy question है guys, बहुत easy question है. Now the thing is, when we are talking about, see, 1740 centimeter inverse. So when we talk about 1740, that is typically for a ester. for a aliphatic ester, isn't it? तो ester कहाँ पे present है? Ester is present in option number A. All right. Ester is present in option number A. So let's say A matches with 3. Then the other thing is chloropentane. Peak intensity M or M plus 2, 3:1. तो आपको पता है that for chlorine, 35 chlorine is to 37 chlorine is 3:1 approximately. So 2 is going to match with B. B matches with 2. अब C के लिए हम चेक करते हैं 1,2 dibromo 2 methyl propane, 2 signals in proton NMR. So obviously both of these methyls are going to be the same. ये दोनों methyl same हो गए और एक CH2 आ गया. So only 2 signals for the proton NMR. So C is going to match with 1. How nice and easy. तो अब ऐसे क्वेश्चन आएंगे गाइस स्पेक्ट्रो में मिक्स वैल्यूज के क्वेश्चन आएंगे. सो A मैचेस विथ 3, B मैचेस विथ 2 एंड C मैचेस विथ 1. सो यस हारिका, D इज द करेक्ट आंसर. वेरी नाइसली आंसर्ड. आगे चलते हैं. आइडेंटिफाई द सीरीज शोइंग आइसोलोबल एनालॉजी. अब सीधा सीधा IR का NMR का क्वेश्चन नहीं आएगा. And you are going to get mixed spectroscopy question just like this from now onwards, because these are more difficult and a student has to know everything. All right, so isolobal analogy question. Which of these are showing isolobal analogy? चलो चेक करें. So there are 7 electrons in this. Let's say total of carbon has 3 electrons bonded. 4 electrons are there, so 3 and 3, 6 electrons, और ये 1 electron, 7 electron, 1 hole and 1 frontier molecular orbital. FeCO whole 5, इसके पास भी एक orbital है. What are the total number of electrons? Iron has 8 electron, this has 10, तो ये हो गया 18, लेकिन plus की वजह से there is 1 hole present, so this is definitely isolobal. It has 1 more orbital. Okay. Now A is isolobal. What about B? CH3 positive. CH3 positive का मतलब ये है कि इसमें से एक इलेक्ट्रॉन निकाल दिया है, so there will be 6 electrons and 2 holes. What about chromium complex? Chromium has how many electrons? 6 plus 10 is 16 and this is 1, so this is going to be like 17 electrons, isn't it? Yes, a carbon has 4 electrons. इसको फिर से देखते हैं. Carbon has 4 electron plus 3 on the hydrogen. So this is 7. 7 को हमने कर दिया है 1 minus, तो ये 6 हो गया है. So B is not going to be isolobal. चलो आगे चलते हैं. C के बारे में देखते हैं. This is again going to have 6 electrons and 2 holes. Nickel has 8 electrons and here it is neutral. So it has 10 electrons and 6 electron from carbonyl, 16 electrons. So this is isolobal again. Okay. A is isolobal, C is isolobal. What about D? CH positive. So carbon has 4 plus 1 minus 1, 4 electrons. And what about CpCO? 5 plus 9 is equals to 14 electrons. So this is also isolobal. A, C and D. So answer is option number B. A, C and D are isolobal. B is not isolobal. Okay. आगे चले. Yes, let's do the next question. All right, so isolobal analogy पे एक complete video है for those who have not yet seen them. There are 2 videos. Please go through it. Okay. चलो next important question. The correct sequence of reagents to effect the following transformation is. Yes, it's a very simple question, very simple one. The correct sequence of reagent बहुत easy है guys. Aromaticity छोटा topic हो भले ही, but it is very important. Every year there is a question on aromaticity. So what is happening over here? We have to convert from naphthalene to the methylene derivative of this 10-annuline system. So what are we going to do? We are first of all going to apply sodium in liquid ammonia, and that is going to convert this molecule into this simple system like this. क्या हो गया है? Birch reduction हो गया है. After that we are adding, ये देखो, DDQ oxidation हम अभी नहीं करते हैं, लास्ट में करते हैं. We first add this kind of a system. All right. Yes, so basically this is a very simple reaction. अभी हम देख लेते हैं कि इसके ऊपर किस तरीके का shift होने वाला है. It is just a 1,5 hydrogen shift that I was saying. It is not a diene. We have to make it look like a diene. So this kind of a shift is required. इसको ये कौन सा type का shift होगा? 1,3 shift or 1,5 shift? So you cannot just do 1,3 shift in a conjugated system like this. अगर ये double bond नहीं होता, if the benzene bond was not present, then you may have transferred the hydrogen over here. But if it goes on the third carbon, then it is 1,3. If it goes on the adjacent carbon, it is absolutely 1,5. कैसे हुआ देखो, 1 for this hydrogen. Okay, in this way, you see. So now it has become a diene. Now the Diels order reaction is going to take place. ठीक है, और ये finally aromatic भी बन जाएगा. So we had to do a 1,5 hydrogen shift followed by 4+2 cycloaddition reaction. So it is not just, you cannot directly do a Diels order reaction over here because यहाँ एक methylene bridge है. How are you going to get that bridge after the 1,5 shift? So easy question but tricky when you are giving the exam. चलो next tricky question. The major product A and B formed in the given reaction sequence are. अब ये जो question है, this is from asymmetric synthesis. So I made you do that already. Let's see. ये वाला question होता है क्या? Try करो. चलो, what kind of a reaction is this? What kind of reagent is this? ये asymmetric synthesis का question है आपका. Major product A and B formed in the following reaction. So you see that this catalyst is the CBS catalyst, Kore-Bakshi-Shibata catalyst with borane. So borane is actually doing the hydrogen transfer, लेकिन कहाँ से करेगा? Okay, that we have to see. So how is it going to go? This is a unsymmetric ketone. While we are doing the CBS reduction, we see कि जो largest group है, the largest group in the two of these group is going to be written on the left hand side. तो यहाँ left hand side में लिखेंगे largest group on the left bottom. Largest group on the left bottom. This is how we will write the molecule CCl3 double bond OPH. Now from above the plane H minus is going to be transferred. ये एक shortcut है, above the plane होगा when it is written like this. So if it is above the plane in this way, then the hydrogen is going to come above and the OH is below. Now ये रहा pH. लेकिन in the option it is not written like this, so I have to rotate it once again. Yes, Harika, see, I think all I have done already for organic is to, I've already created a complete playlist of organic on YouTube. So you can go through the Claydon series if you want. And if you want to join our batch, you can join the target batch right now. Alright, this is going to be completely for the preparation of December 2024 examination. Alright, so you can join the batch, and if you want to study for the basic, you can go through the Claydon series also. It's going to help you a lot in doing the basics nicely. So I am rotating this molecule once again because in the question it is written like this. pH is written on the left hand side. If I rotate, the OH is going to come on the top and the hydrogen goes in the bottom. ठीक है, ये ऐसा हो गया. You have to be careful. Now the OH is above in this option. 3 is wrong, 2 could be correct and 1 is again wrong. तो ये जो asymmetric synthesis होती है, this is very selective and you have to like be very careful. Now this is what we have. The next part of the question is OH minus NaN3. So sodium azide is a nucleophile azide. That azide is going to basically replace the OH from over here, and definitely it is going to be a SN2 reaction, which means that the azide is now going to be sitting at the bottom and the hydrogen goes above. ये ऐसा बन जाएगा, ठीक है. And what is the CCl3 going to do? OH minus is going to attack over this carbon and one by one the chlorine are going to leave. Let's say there's a chlorine, one by one the chlorine leaves and it's just hydrolysis to finally give you the carboxylic acid. So answer is option number 4. ये कौन सा रिडक्शन है? CBS रिडक्शन है, कोरे बख्शी शिबाटा रिडक्शन, asymmetric synthesis का एक क्वेश्चन है, ठीक है. Moving onwards to another important question of photochemistry over here. Formation of molecule A and B will involve you know, the more you practice questions, the better you are going to be at your subject. So I have already made a table. If you look at my Instagram channel or Facebook or the community post, I have posted a table in which you can spend your last 10 days before examination by following that routine. I think that kind of routine will work for everyone, क्योंकि उसमें कितना प्रैक्टिस करना है, कितना रिवाइज करना है, सब कुछ बहुत क्लियरली मेंशन्ड है. Day 1, Day 2, evening, morning, afternoon, everything is mentioned. So if you haven't already seen, please see that routine for the last 10 days and I think it is going to help you. चलो, mechanism for the formation of molecule A and B. Now these are very repeated questions. This is nothing new. They are not asking you anything new over here. जो पहले पूछा है उसी को mix and match करके कुछ बना दिया एक नया question. So what do I have? I have this beta gamma unsaturated ketone. Fine. In the presence of light, what are the two possibilities? If a cyclopropyl ring is forming, for example, I am doing the numbering 1, 2, 3, 4. On the 1 and 4 position, if you find somehow that 1, 2, 3, 4, let's say there's a double bond like this, थोड़ा सा ये, हाँ यहाँ पे आएगा, एक कार्बन कम होगा. So if you are able to find that on 1 and 4 position you are having unsaturation in the presence of light, the most obvious thing that would happen is this kind of a 3-membered ring formation, O radical and this CH2 radical. Alright, then the ring can break down from over here to give you back the ketone and also give you this 3-membered ring. ये क्या है? Oxidipymethane rearrangement. So is it possible? If you see the 3-membered ring, it has definitely happened. And ring contraction हुआ है तो definitely oxidipymethane rearrangement. The other thing that can happen is, see, ये जो unsaturation है, it is far away. So I can do a Norrish type 1 cleavage. Norrish type 1 is the alpha cleavage. After doing the alpha cleavage, I can have these two radicals over here like this. Then what is the possibility? Possibility ये है कि यहाँ से मैं ऐसे break करके एक alkene बना सकती हूँ. I can make an alkene on this side because it's a tetra substituted alkene, so no problem. and I can have a radical over here. तो अगर ये combine करेगा तो it is going to give you a 4-membered ring like this. So it is oxa dipymethane rearrangement and Norris type 1 reaction. Okay, not so difficult guys. Repeated question, हर बार photochemistry में लगभग same question आते हैं. So I will be informing all of you, for those who want to prepare for the December 2024 as well as the GATE 2025 examination. This course is for the next 8 months. तो आपको जो टोटल वैलिडिटी मिल रही है इसकी कोर्स की वो है 8 months वैलिडिटी, and the validity is going to be till your February 2024 examination. The course price is only 6820, in which you are going to have all of these important topics of organic, inorganic, and I will also be uploading physical chemistry content in this course. So this is going to be a recorded course, mostly recorded course with live and practice sessions, doubt and practice session live. Topic wise PYQ assignment, complete test series. You don't have to buy the test series separately, it is already included, and doubt support WhatsApp group as well as the practice session. All of these are included till your February examination. So 8 months validity का ये course है. इसके साथ ही साथ for those who are in their MSc, they can choose the Alchemist detail batch for the CSIR NET preparation, because in this batch you're getting a extended period of time of 1 year and you can prepare and re-prepare and practice. आपके पास इतना टाइम रहेगा क्योंकि कंटेंट बहुत सारा है, उसको कंप्लीट करने के लिए आपको टाइम भी पूरा चाहिए होता है, एंड इट इज़ वेरी इंपॉर्टेंट दैट यू रिवाइज whatever you have studied and practice whatever you have studied. So this is going to give you that much time. So every student who is there in the MSc or MSc final or BSc and thinking about the GATE and CSIR NET exam, they can join this course as well. For those who want to only do the practice before examination, अभी 10 दिन बाकी है, तो आप अगर practice करना चाहते हो, only in 899 you can join up the course. Mock test, complete mock test. There are 43 tests for all the student, topic wise and detail, and for the students who want to join only aptitude course, you can join up Christy Verghese course. All of this is available on the app Rasayan Academy. ठीक है, अब हम आगे चलते हैं. We move onwards to next question, which is again a previous year question only. The intermediate A and the major product B formed in the given reaction respectively are. Okay, so what are the reactions A and B? A और B में क्या बनने वाला है? Intermediate and final product. All right, so it's a very simple question guys, very simple one. Intermediate A and the major product B. So again, as I'm informing you all, ये आज का हमारा second session था for the examination of CSIR NET June 2024. We are going to have 5 more sessions, total of 7 sessions. Free session will be there. So again, I will be seeing you all tomorrow at the same time, 8 PM. ऑल राइट, 8 बजे हमारा क्लास का टाइमिंग होता है. आई थिंक एवरी वन इज़ अवेलेबल एट दिस टाइम, सो बी प्रेजेंट गाइज, and also please share this session with your friends as well as share the timing with your friends so that they can also take benefit of these sessions. All right, so what about this question? बहुत easy है और ये एक repeated question है. So if you are practicing a lot of PYQ, you will identify if there is a repeated question or a concept. Okay, so what is happening in the presence of heat? Right. Yes. Yes, Prajwal, you're saying option number 3. चलो देखते हैं तो क्या हो रहा है. देखो ऑप्शन नंबर हीट के प्रेजेंस में द मोस्ट प्रोबेबल थिंग दैट कैन हैपन इज द रिंग एक्सपेंशन. So when the ring is actually getting expanded, one of the bromine leaves और दूसरा bromine ऐसे के ऐसे रहने वाला है, ठीक है. और ये जो bromine है जो यहाँ रह गया, see this one bromine stays and one bromine goes, and on this carbon the bond has broken, so on the adjacent carbon there is going to be a positive charge. What is the next reaction? Nothing, no reagent is given, so the Br minus has only one choice to attack back, and yes, 3 is the correct answer. Why 2 is not the correct answer or 4 is not the correct answer? Because you are not going to break the bond which gives you a smaller ring. You will definitely want the ring expansion, and here this is a allylic carbocation, so it is more stable. और यहाँ पे कार्बोकेटाइन इस पोजीशन पे है आउटसाइड द रिंग, इट इज़ अ 5 membered रिंग, यू वोंट फेवर दैट. तो 3 इज़ आवर करेक्ट आंसर. और यहाँ क्या है, पोजिशनिंग इज़ रॉन्ग, द पोजिशन इज़ रॉन्ग, सो 1 इज़ नॉट द करेक्ट आंसर. Next good question, the correct set of reagents required to convert ethyl benzoate to ethyl benzene is. reagents का question है, बहुत simple. You know what is the best way to study reagents? It does not start with actually studying from the book. No. Best way to study reagents is it actually starts by solving PYQs. जितने भी reagents के ऊपर बेस करके PYQs है, just bring them all together. Alright, all the PYQs which are based on reagents topic, just bring them all together either in your notes because you have been practicing PYQ. तब आपको पता चलेगा that what are all the important reagents which are being asked. They are repetitive. सारे repetitive है. In the previous year questions, if you see, it is all repetitive. So this is the best way to study reagent. PYQ खोलो, जितने भी question है reagent पे, just bring them all together either in your notes or in a word file wherever possible and practice through that. Reagents is not going to be a very big topic anymore. Okay, chalo. So yeah, what is the correct answer to this question? Alright, don't depend on any coaching's note to do that, क्योंकि कोचिंग के जो नोट्स होते हैं वो अपने हिसाब से बनाते हैं लोग, लेकिन आप जो अपने नोट्स बनाओगे वो अपने हिसाब से बनाओगे. तो जो भी सबसे ज़्यादा डिफ़िकल्ट टॉपिक है, द मोस्ट डिफ़िकल्ट टॉपिक, you must note down all the PYQs together so that you can practice and your syllabus scope decreases and comes to a point which you can very easily practice and have your expertise in. So yeah, correct set of reagent required to convert ethyl benzoate. अब कई लोगों को ethyl benzoate लिखना नहीं आता. Whenever you are writing an ester, ये जो ethyl group है or whatever is the substituent on the oxygen, that is always written first. So this is ethyl and this part is the benzoate part. You have to convert this to ethyl benzene, that is PH CH2CH3. इसमें convert करना है. How are you going to do that? Looks like you have to convert the carbonyl group into something, into a carbon. कैसे करेंगे? Wolff-Kishner reduction है? नहीं है. There is no reduction. Is there any kind of let's say Clemmensen reduction? वो भी नहीं है. Reduction नहीं है. Excess of Grignard is going to give you a tertiary alcohol. That won't solve the problem. Let's try out these two options, number 2 and 3. ये क्या है guys? If you have seen this, what is this? It is finally going to, after a methane MEH removal, it is going to actually give you CH2 double bond TiNO3. CP2. What is this? It's kind of a carbene thing. ठीक है, ये एक तरीके से कार्बिन जैसा है ये मॉलिक्यूल. So what is going to happen? You are going to get the conversion of Tebes reagent बोलते हैं इसको. You are going to get the conversion of the carbonyl. It's a organometallic compound. Only it is going to touch the carbonyl, not the OET group. So double bond CH2 OET, ये होता है conversion के लिए use. After that hydrolysis is present. So what is hydrolysis going to do? देखो ये एक नया group बन गया है. This is vinyl ether. So vinyl ether in the presence of acid always does the reaction in this way कि यहाँ से एक proton ले लेगा, ठीक है, and that is going to convert to PH. This carbon is going to have a double bond OET positive and this has become a CH3. Now what is the next step? Hydrolysis further is going to completely convert this into a ketone like this. Ketone बन गया. इसके बाद क्या होगा? प्रोटेक्शन. इथेन 1,3,1,2 डाइथायोल, मतलब कि ये हो जाएगा इस तरीके से प्रोटेक्ट. इट इज़ प्रोटेक्टेड लाइक दिस बाय इथेन डायोल. Now finally raninical. What is raninical going to do? It is very popular for doing desulfurization. It breaks right from over here और ये बन जाएगा वापस से डाइथाइन मॉलिक्यूल और ये क्या है? एल्केन. So this is going to be the correct answer, option number 3. All right. So first you are using Tebes reagent, hydrolysis of this vinyl ether to finally give you the ketone. Ketone converts, the carbonyl group is protected और ये बहुत अच्छा application है to completely like reduce it. Okay, so 3 is the correct answer. ये क्यों wrong है? Why can't we do this kind of a reduction? Because it is not a carbonyl anymore. After protection it is not a carbonyl and it is not the correct reagent कि ये alcohol है, alcohol पे कुछ असर नहीं होगा hydrazine का. So this is going to be the correct answer.